Well, good morning, everybody. Welcome to our new webinar from Redgate Software called Extending DevOps Practices of SQL Server Databases. Today we're going to hopefully just discuss a little bit with a few slides of what we mean, try to set the stage and the frame of reference for everybody, and then Arneh's going to do a big, long demo, hopefully, and you guys will have lots of questions about what you want to see there. I'm Steve Jones, and I run SQL Server Central. I was a founder of that site, and I also work for Redgate as an evangelist. All my contact information should be up on the screen there, so please feel free to get a hold of me. I've been working with SQL Server and software for 25 years, developing software, administrating databases and infrastructures, and managing people that do both sides of the DevOps coin. So I've had a lot of different experiences in my career, and it's interesting to see that a lot of things that I've done over the years are kind of repeating themselves, and what we're calling DevOps is not necessarily anything new, but it gives us a way to just kind of talk about it. And with me today, we've got Arneh Eskandari. Arneh, you want to introduce yourself?
Absolutely. Hey, everyone. My name is Arneh Eskandari, and I've been with Redgate for almost 6 years now. And as part of my role in Redgate, I've worked with a lot of customers, small shops, large IT shops, in terms of helping them get up and running with a new DevOps process and utilizing Redgate tools to integrate their databases into their application lifecycle management and have a solid pipeline of changes from both application code and database going through the DevOps process. So here are my contact details, so if you guys have any questions, then feel free to reach out.
Excellent. Thank you, Arneh. Arneh's one of our very talented sales engineers, so if you decide ever to move forward with Redgate, then he's probably one of those people you'll talk to. So let me move forward here. So our quick agenda here, we want to just talk a little bit about Redgate and what DevOps is and some of the ideas from a theoretical or overview standpoint of what we want to show, and then really we want to spend most of our time in the demo and trying to show you how things actually work and how you can better develop database software and get those changes deployed. A couple of quick housekeeping items so you're aware. We are recording this webinar, and so we do have that available. You'll get a link later on where it'll be available. We do have all these past webinars up on our YouTube channel, and so every month Arneh and I, or Grant and Arneh, or me and Grant, some combination, try to do a webinar, and we usually vary the tools that we plug into so that you get a variety of different views, right? So if you use TFS or Git or Subversion or something else, we try to get you different ideas there of the different tools that you do and the different options you can use. I think that's it. Oh, we also have the questions on here. There's the questions panel in your GoToWebinar control panel. Please feel free to ask questions as you want, and let's get going. So Redgate is a software company. I've known Redgate really since about the company started. They were actually one of my first customers when I started SQL Server Central. But since then, they've developed lots of tools that help you build database software and .NET software and do monitoring and do other things as well. Our goal is to really build these ingeniously simple tools, and we try to make things easy and simple to use. And so we've got a poll here that you can take to see what you guys are using. Now, we sell our tools to Fortune 100 companies all over the world, all different industries, all different types of development platforms, development ideas, all that kind of things. And so really our goal in Redgate is to just help you build software better. And now as we move into the DevOps area, we want you to build better software faster. We also support the community. Part of what Redgate believes in is not only do we sell software to the community, but we want to support the community from the knowledge standpoint, that we are part of the community. And so we have simpletalk.com and SQLServerCentral.com where we provide information that isn't specific to Redgate, isn't specific to our products. It's really to help you get better at your job, to help you become better technologists across the years. And so we firmly believe in that. And it's one of the reasons I'm an evangelist for Redgate, and Grant Fritchie is as well. We travel all around the world speaking to people about software, trying to get them better at using SQL Server. Sometimes we talk about Redgate, sometimes it's just generic technology, but we really want to be a part of the community. So let's close the poll. There we go. And let's jump further. So the DevOps idea is really that we want to bring developers and operations together, that we don't have this wall where we throw code over and we yell at each other, that we really want to make sure that everybody works together. And part of the problem with that is that our data is a challenge. Our databases have to maintain state because we want to keep data from deployment to deployment as our software changes, and we want to ensure that we keep that data intact, secure, and available all the time. And that's one of those challenges when we try to make a database change in a process where there are developers that build application software, web software, are trying to go extremely fast. We got to maintain state, which is not something the application people have to do. What happens when we don't have a good development process? Well, I'm sure all of you have struggled at different times. You've had different things go wrong at different companies or different projects or different times. And often what really becomes is that our databases are a bottleneck because we get scared that our changes are going to cause downtime. We're not coordinated with the changes that are occurring in the application. We don't often know what's changed, or the developers don't know what's changed by the operation people, and vice versa. Certainly rolling back is always a challenge for databases. Because of that data, it's just a difficult problem. And so as we get scared, as we develop fear, we release less often, we stack up more changes, and we create more risk. And a lot of this just results in just kind of some friction and some inconsistency in how we release application software and database software, and that results in inefficiencies where we spend a lot of time doing it. So we're trying to make this better. When we talk about database lifecycle management, or DLM, and database DevOps, what we're really trying to do is make things repeatable and reliable, and we're trying to lower our risk. So we want you to understand and be aware of what's going to happen when you release the software. I want to know what the impacts of the change are. We don't want to forget anything. We want to make sure the complete releases go out. And we want to eliminate all the human error. We want to make things very repeatable because we use automation as much as possible to ensure that we just don't make mistakes. As humans, we're really good at creativity, we're really good at building solutions, but we're not great at repeating the same thing over and over again. So we want to try to make them more repeatable by using a DevOps process. We also want to try to make smaller units of change. So we want to be able to deploy things in smaller batches because that lowers risk. In the database world, that gets challenging because sometimes we think, I need to deploy a whole bunch of table changes and then a whole bunch of view or store procedure or function or other changes as well for our application. And ideally, though, what we'd want to do is release those in smaller increments. Can I change one table without affecting my application, and then another one? And then when I think I've got enough stuff, I can add in store procedures and other code and my application code and all that other stuff. So we're trying to do small units of change to lower our risk so that we can stabilize and understand what's going on. And then, of course, we want to test our software as we're doing this so that we try to understand, if I make a table change, is that breaking the application? Is it breaking any other things that are occurring inside of our database, right? Can I still handle inserts if I've added or altered a column? We do that with automated testing, and that's my big focus as well. I really believe in automated testing, which is one thing in the database world we're really immature at doing. So we're hoping to show you some of this. Puppet Labs does a State of DevOps report every year, and they've done it, I think this is the 4th one now, or 5th one, but they survey, used to be hundreds of companies, now it's thousands of companies all the time about how they deploy software, and are they using a DevOps process, whatever that means to them, and what does that mean. And what they tend to find is, first of all, the #1 predictor of high IT performance is version control or source control. And if you use version or source control, and I'm sure some of you do, that already gets you so much further along because it provides you some stability and some basis on which you can then track and move all your changes around. But more importantly, the IT organizations that perform highly, that are more agile, that deploy code regularly, they have less failures in their deployments, they have less bugs in their applications, and they're able to achieve more profitability in their organization, whatever that means, whether that's dollars, whether that's more services or something else. They're just much more likely to get things done because they release more often, because they can count on these releases working. They have the opportunity to get code out to their users and see what the feature usage is or what the value is. For myself, most of my career, we've spent a lot of time developing code, and then by the time we get it to users, sometimes they don't need it, or it's not what they want, or they need to do something different. If I could release in smaller chunks and have them actually start using smaller pieces, it helps to target my efforts in an area that are more important and more appropriate for my organization. And that's what we're trying to do. So what can Redgate do for you? Well, what we try to do is give you the option to use lots of different tools and platforms and products, and we plug into various places in the process so that we smooth out your database development. Now on the screen you should see developers on the left-hand side and operations and production on the right-hand side. And what we really try to do is, as we flow code from developers to version control to continuous integration, etc., we want to plug into various options. So if I start on the left, we want to make sure that database developers use version control just like application developers. And as you can see at the bottom, we don't care if you use Git or Perforce or Vault or Mercurial or Subversion or even SourceSafe or CVS or really any version control product. We plug in with SQL Source Control to help you ensure that your code gets there. And then we also provide tools like prompt and test that allow developers to be more efficient. And so as you create your code, we want to make sure that all that code gets stored back in the version control system. And in our particular philosophy, as Arneh will show you, we always store things as create statements at the head of your version control. So the latest version is always a create statement. That way you can always see what a table looks like or any other object. And then we want to implement continuous integration. Some of you may be application software developers. You've been doing these for years and years and years. Some of you may not be using it. Some of you may do daily builds or weekly builds, but really we want to help you include a database in a continuous integration process. And again, we don't care whether you use Bamboo or Cruise Control or TeamCity or TFS or Jenkins or Hudson or anything. We just want to plug in there and allow you to build and test a database inside of your continuous integration process. And then we want to help you with release management. And we have our DLM automation product that really helps kind of build and deploy database code to multiple environments and do it in a consistent way so that when I release the test or QA or staging or beta or user acceptance or pre-prod or any environment that I have, I do it in the same way. So I actually practicing my deployments and I have confidence that things will work. And if they don't, then I actually catch that early on. I catch it in test or QA and not catch it in production, so I can fix things. And then when I'm ready, I deploy to production in the same way that I've already done many times. I can have these gated where humans have to review them. I can have them gated where an automated process has to pass or assert something is true. I can do whatever I want. I can use whatever tools I want. I can use Visual Studio Release Management, Octopus Deploy, Bamboo, any tool out there. And then, of course, once it gets to production, we're not done. We want instrumentation and monitoring so that we want to know how our code performs, right? Our users using it and things. And so we have SQL Monitor, DLM Dashboard, and other things, as well as SQL Backup to help ensure that your data is there. So let's jump over to the demo. Arneh, are you ready? Can I turn this over to you? All right, so
let's do this. All right, excellent. Let me go ahead and share my screen.
All right, it should be coming up in just a second. And again, if you've got questions, please use the questions panel, punch them in there, and I'll try to answer them as Arneh's doing the demo, or I'll ask questions to him. And then, again, this is being recorded if you have to drop out. All right, I see your screen, Arneh. Go ahead.
Okay, perfect. So we're now going to go through that workflow that Steve just described as part of the diagram. So we'll demo a full end-to-end process of making changes to your databases in your development environment, getting those changes validated through that through an automated build process, and then releasing those changes out to your higher environments through a release management tool. So for this demo, we'll show you how Redgate tools can nicely integrate into an existing infrastructure or framework. So for source control, for instance, we'll be using Git. So I use GitHub for the purpose of this demo, and I'll be using TeamCity and Octopus Deploy for my builds and also releases to my higher environments. So the database that I'll be working with today are the Stack Overflow database. So this is a copy of the Stack Overflow database that we'll be demoing against. So I have a test database, a UAT database, and I also have the production database here on this other SQL Server instance. So the first thing I need actually in this case is a dev copy of this database. So I can't just go to any of these environments and start making changes. So I need to spin up a dev environment. Now I could do this from source control. So my database is already in source control since this is an existing project. So I could go link my database to the source control repository in Git and bring a copy of that down to and create a database off of that. But let's say for this instance, I actually need data to go with the database for my development process so I can do some testing on real data. So obviously we don't keep all data in source control, but for the purpose of this demo, let's say that we need all data, and we have a lot of data on the database. So what I'm going to do is I'm going to utilize our SQL clone technology, which is one of the new products that we just released, to quickly spin up a new copy of a database from an image of our production, so which will include all the data in our production database. So you can see the database is at 113 gigabytes in size. So I want to go ahead and create a clone off of that and treat that as my dev database and start making changes to it. So quickly going to go ahead and clone this to my local instance. And I'm going to call this Stack Overflow Dev. And here you can see it's now creating the clone off of the image from our production database. And it should go ahead and create that in a matter of seconds. So here we go. So you can see I have a dev database now that I can work with, and it literally took seconds to spin up that database. So I'm going to go back here, refresh my server, and you'll see that database in there now. Here's my dev database, so I can go ahead and start making changes to this one. And I have to quickly show you. So this is the full-blown database. It's just like a normal database. As you can see the size is showing as the full size of the database, so 110 gigabytes in size, but it only takes, a few megabytes of disk space on my local machine, thanks to the clone technology. So I've got my database. Now I can go ahead and start making changes to it. So the first thing I need to do is to link this database to my source control. So I'll be utilizing SQL source control here, which is what you see here in the middle. This is one of our plugins which acts as a bridge between your development environment and your existing source control system, whether it's Git, TFS, Subversion, or any other source control system that you might be using. So I'm going to go ahead and link this to my Git repository. Obviously, the workflow with Git is that you commit your changes locally first. So I'm going to go ahead and link this to my local Git repository. I already cloned the repository from GitHub down to my local just to save us a bit of time. So I end up sitting here under my Git repos and Stack Overflow. Okay, so I'm going to go ahead and link to that repository. Okay, so my database is linked. Now, this is an ongoing project, right? So there's not some new changes to the database that have been checked into source control from the time we created that image that I created my clone from. So that means source control is slightly ahead of that image that I just cloned from. So I need to get the latest version from source control first before I can continue as a developer. So I'm going to go to the Get Latest tab here, and I'm going to pull from the remote repository just to make sure I'm working with the latest version of the database. And here you can see it's showing that there's 2 new store procedures in source control that I don't have on this clone. So I can easily see what objects they are and what's inside those objects. So looks good. So I'm going to go ahead and apply these 2 objects to my local database. All right, so now if I go to my store procedures, I should have those new objects in there. Here we go. So now I've got the latest version of the database from source control. So now I can go ahead and start making additional changes to it as a developer. So let's go ahead and get started. Let's say that we want to actually modify one of these objects that I just pulled down from source control. So let's say we want to replace the select star with some columns. So let's say we want to do this. I'm also going to go ahead and format this using SQL prompt to make it look good and readable. And I'm going to apply my change. So now as part of SQL source control, you also have the option to source control lookup data or reference data. I think this is a question that one of our audience, Troy, asked earlier, is how do you keep, config data in source control, and he's specifically asking about large config data. So so you can do that by going to other SQL source control tasks and link or running static data. What this will do is that it will give you a list of all tables that you have in your database, and from there you can select the tables that you consider as config tables or lookup tables or reference tables. So in this case, we have link types and post types as two tables that are that we're source controlling in terms of data. Now, if you have very large amounts of static data or lookup data in your tables, that might actually introduce some performance impact on SQL source control. So it might take a bit longer for SQL source control to refresh the changes that you need to commit to source control. So if you have really, really large amounts of data, like thousands of rows of records, or anything more than that, then you might actually be better off utilizing our migrations feature that we'll be touching on in a bit to deploy those data changes, as opposed to linking the data directly to source control. But in this case, I've linked the data to source control, so we'll also make a data change to one of these tables and get that data change into source control as well. So let's go ahead and insert a new record in one of these tables. So let's say we want to add a new link type. Okay, let me just quickly check, see what data I have in there already. Okay, so we have linked and duplicate, so let's add a new one. And let's call it unlinked. All right, so made a couple of changes here. So these were a couple of simple changes. Let's say that you also have some refactoring changes that you want to make to a table, such as adding a new not null column to an existing table. So for those of you who are familiar with compare tools in general, that's actually one of the limitations of compare engines. Is in specific refactoring table changes, they actually can't go through the right behavior in order to deploy those changes successfully. So if you add a not null column to a table, then obviously you need to set some default data that goes as part of that column. But compare engines only pick up the schema differences, and that's what they try to deploy. And as a result of that, they are very likely to fail in those scenarios. So I'm going to show you how we work around that through our SQL Source Control tool and the migrations feature of SQL Source Control. So looking at our table, so here we have this table, both types, and let's say we want to add a new column to this table called description, and it's going to be a not null column as well. So I already have a script here that I've saved up just to save us a bit of time. Okay, so what I'm doing is I'm adding the description column as nullable first, run an update to put some default data in there for the existing mode types that already exist in production and my higher environments, and I then change it to not null. So I'm going to go ahead and apply this change. Okay, so now I'm going to go ahead and commit these changes to source control. So commit changes to source control. Okay, I'm going to select the data that I want to put in source control. And one thing you notice here at the top, it's saying that some of these changes could result into deployment error. And this is specifically talking about the change that I made to the word type table and that new description column that we added. So if we were to let SQL Compare handle this deployment, it would try to add a column as not null, and the deployment would fail. So it would come back with a SQL Server error because it just has no way of knowing what data should go with that change to make it successful. So to override that behavior, we can use a migration script here to tell Compare what to do when it's deploying this specific change. So I'm going to go in and add a migration script. And I only need to add a migration script for the vote types table. Get poster procedure, SQL Compare can handle that, okay, so I don't need to worry about that. So I'm going to go ahead and say generate script. And the script that gets generated here is the script that Compare would try to run in order to deploy that change successfully. So as you can see here, what it's trying to do is that it's trying to create a temporary table and then build a table from scratch in terms of the columns and everything else, and then copy all the data to that table. But even that's not going to help because it still will end up adding a description column with no data in it, and that will fail. So I can just go ahead and replace this with the script that I executed to apply that change. So I'm going to copy this, and I'm going to save this as a migration script for the changes that we apply to the vote type table. So save and close. Okay, now then this is going to refresh the page, and now you can see that there's a new migration script that covers the changes that we made to the vote types table. So the end result is still the same. We're just adding a new not null column description, but how we do that now is done through this migration script that we provided to the Compare engine. So later on, when we do deployment, Compare will see that there's a migration script for this change, and it will run this script as opposed to generating its own default. All the other changes are fine. I can go ahead and commit those to source control. So actually, let's commit these two changes first. So so with migrations, generally, you need to commit the migration script first before you commit any other objects, or commit other objects first and then commit the migration script. And we do that so that way we can keep track of what state the database was at the point you created the migration script, so we can get the database to that same state if needed before we run your migration script on the higher environment. So I'm going to go ahead and commit this change to objects first. So we alter the get posts Sprout and added a new data to link types. Okay, let's go ahead and commit that. Okay, now I'm going to go ahead and commit the change that I made to the vote type table. So we added a new column. I'm going to commit that as well. So, so here is just giving me another warning, but we already took care of this through the migrations. So I'm going to acknowledge it and let it get checked into source control. So we're using Git, right? So the workflow is that you commit your changes locally into your local Git repository, and then from there you push it to your remote. So here I'm only working on a single branch, so working on master branch. So I'm going to go ahead and push these changes to master in GitHub as well. So let's go ahead and do the push. Okay, so that should have updated our GitHub repository. So let me just quickly double check that. Okay, so yeah, so here are the changes that we just pushed to GitHub, and I've set up a continuous integration process. So every time I push a change to my master branch in GitHub, that goes ahead and triggers a build in TeamCity. So you can utilize our BLM automation component that comes as part of our SQL tool belt to configure your build and release steps in an automated process, and be able to basically validate your database changes alongside your application code that you might already be doing builds against in your CI environment. So I'm going to bring TeamCity over here, and as you can see here, my build already started. So I'm quickly going to walk you through my build steps while that's running. So as you can see here, I have 4 build steps in my CI environment. The first build step is utilizing Redgate's BLM automation build. So we offer a set of plugins for different build systems such as TeamCity, Bamboo, TFS, or VSTS. So you can utilize these plugins to define your build steps. Otherwise, you can just use our PowerShell commandlet to write a PowerShell script to run as part of your build. So what we're doing as part of the build process here is that we're validating the schema of your database that you have in source control against a temporary empty database to make sure that your database can be built from scratch and that you don't have any broken dependencies or any SQL Server compilation or syntax errors with the migration scripts that you've put in source control. So if this build is successful, then we go ahead and package up your database into a NuGet package. And that NuGet package becomes the lockdown version of what you have in source control, and that artifact can be used as a source of deployment going to your higher environments. So since we're using Octopus Deploy as our release management tool, then my next steps are basically sending the NuGet package to my Octopus Deploy server. And then from there, I'm also utilizing the Octopus Deploy command line or the Octopus Deploy plugins to TeamCity to automatically create a release and deploy the release to my test environment. So I've set it up in a way where, you know, if I have a successful build, then I want that build to get deployed to my test environment automatically without any intervention. So let's go back to our build, and here you can see the build was successful. So we were able to successfully validate our database schema as well as the migration scripts that we checked into source control, and that has given us an artifact, which is that NuGet package that I mentioned earlier. And if you look at the content of the NuGet package, it's the same folder structure as what we put in source control. So we have the custom scripts or the migration scripts in here. We have the lookup data in here, and all the other objects that exist on our database. So we're carrying the state of the database that we want to promote to the other environments, and this is what we'll compare against the other environments to generate the actual update script that we need to run against our higher environments to do the deployment. So,
hey Arnie, real quick, somebody asked if you could show a test or two, show how you've got a test, like what's there.
Yeah, I actually don't have automated tests in there on this project, but I could quickly show you. So there's a bunch of different steps that you can utilize as part of your build process. So if I go to my configuration settings and if you look at my build steps, so as part of Redgate, we provide you with a set of different functions that you can utilize in as part of your build process. So the first one is the build that we just looked at, but you also have the option to run automated tests as part of the same process as well. And this automated test is broken down into two different frameworks. One is called SQL Cop, and the other one is called T-SQL-T. So I'm going to quickly show you. I don't have any of those tests on this database, but I can quickly show you one of my database where I have some of those tests installed, so you can get an idea of you know, what they are and what they look like. So if I go to, say, this database here. So SQL Cop and T-SQL-T are the two frameworks that we support as part of the automated testing process. SQL Cop, just like .NET Cop, is a code analysis testing framework where you can run some automated tests to check for coding standards or best practices. So what that means in terms of databases is that you can basically make sure that your objects are created following a specific naming convention. So in this case, you know, we want to make sure that no store procedures are created with SP underscore because that's bad practice. So I have a test here that will catch any store procedures that start with SP underscore, and that's user store procedures, obviously. So the good thing about this is that, you know, when you install these testing frameworks through our SQL test tool, which is what you see here at the top, these objects will get added to your database automatically, and these are out-of-box tests that you can just run on your database without having to write any SQL. But if you want, you can obviously customize these tests. So these are just SQL and store procedures. So if you want to customize the behavior of any of these tests, you can go in and modify the SQL behind these tests and save them and check them into source control. And once these tests are checked into source control, then you can go ahead and run those tests automatically as part of your build process. The other framework was TSQL-T. TSQL-T is the unit testing framework. So there's a bit of learning curve to TSQL-T because you basically need to learn about what each of these individual objects do and how you can use them. And using these objects, then you can write additional store procedures that will basically be used as unit tests on your database. All right. Anything else, Steve, at this point? Any other questions? I think it might also help if we run one of the polls to see what source control system some of our audience are used to or are currently using.
Yeah. Let me run a couple polls. There's a couple of questions. So you kind of handled the one on. Let's see. Let's launch this poll. Somebody was asking a few questions on clone, and I don't want to dig deep into clone, but just next Wednesday, we're actually doing some live broadcasts throughout the day on clone, how it works, how you can use it, that kind of thing. So if you're interested, check those out. We can integrate with TFS. So somebody was asking, in terms of what we're doing, the build and release and source control, integrate with TFS as opposed to right now. We're just doing Git and TeamCity and Octopus Deploy, but we can integrate with any of those, right?
Totally, yeah. So TFS, it's definitely one of the, I guess the frameworks that people are starting to utilize more now that they've come out with version 2015 and 2017 now, or even VSTS. So yeah, so we do support TFS as a source control system as well as their build and releases. So I actually have another project here that is utilizing TFS for both source control as well as build and releases in TFS. So as I mentioned earlier, we have extensions for TFS as well. That makes it really easy for you to go in and define your build and release steps. Or you can just utilize our PowerShell commandlets as well. So yeah, hope this answered the question.
Yeah. So Arne's showing now. I put it in the documents as well, and all the questions and answers will be posted with the webinar or the recording. Sorry, but we've got these marketplace tasks that Arne has here.
Yeah, exactly. Yeah.
So those work. And let me launch this CI poll real quick. So if you guys are using CI systems, we'd like to know because we're showing today TeamCity, which Redgate. I think we've partnered with them. We like the JetBrains TeamCity concept, but we certainly do work with all these products. I mean, I love VSTS, Arne. I don't know how you feel, but I think VSTS is fantastic.
It is, yeah. It's absolutely great. I wasn't a big fan of TFS until version 2013, but once they released 2015 and update 2 and VSTS from there, it's really great. It works seamlessly. It's easy to get up and running with, and it's really easy to add new tasks, whether it's build task or release task. Everything's nice integrated into a single UI and framework. So I love it.
Yeah, I mean, it's coming on fast, and it's actually. I tend to demo with VSTS on my laptop, so I'll use a local agent to do the build and release because when I run, I think TeamCity is great and Octopus Deploy are fantastic products. When I'm trying to run with less resources, there's a little bit of overhead, and VSTS is a little bit quicker for me to get going, but
yeah, exactly.
They all work fine, so you can use whatever. All right, let me close this poll and let you move on.
Okay, perfect. Thank you. So so as I mentioned, my build process actually triggered an automated deployment to my testing environment. So here's the project. For those of you who are not familiar with Octopus Deploy, this is specifically designed for managing your releases for your software to your hiring environments. So you can easily go in and define what your environments are. So you can see testing, staging, and production. And you can define your projects, whether it's a .NET project or any other type of project. And we provide you with the functionality to easily integrate the databases into that same release pipeline. So the project that I'm working on is the Stack Overflow project. As you can see, my test environment just got updated with the new release. So I'm going to go into that and see actually what was deployed as part of this this release. So before we look at what's been deployed, quickly want to walk you through my deployment steps that I've configured for this release. So if we go to the process here real quick, so as part of Octopus Deploy, the first thing we do is that we unpack the NuGet package, so just to get access to the files that are within that NuGet package. And then here I'm utilizing our templates, which utilize the PowerShell commandlets of DLM automation in the background to define my deployment steps for the database. So you can have both your database and the application code deployment under a single umbrella or a single project, or you can have them under 2 different projects. So either way works fine, depending on what your requirements are. So first thing I'm doing here is that I'm creating a database release. And what this means is that it runs a compare between NuGet package and the target environment. And based on that comparison, it figures out what it needs to deploy or what update script it needs to run in order to apply those changes successfully. So what this step basically creates that update script and a report of what is being deployed, but it doesn't do any deployments. And so what I've done here is I've included a manual intervention step to manually review the deployment before it hits my staging and production environment. So no manual intervention for testing, so I was able to deploy to testing upon a successful build without any manual intervention. But for staging and production, I've just put in a manual intervention step for either DBA or whoever looks after those environments to quickly look at the changes that are being deployed and make sure that they're happy with it, and then approve it. Once it's approved, then its final step is to execute the script that we've generated at step 2 onto the target environments. So we deploy to testing successfully. So if I go back in here, we generate a set of artifacts for each of your releases for each individual environment. So if I click on this changes.html file, this is a report of what is being deployed, or what has been deployed in this case, and including the update script. So here it shows me a report of what objects have been modified or deployed as part of this. So you can see here's a table. We added a new column for it, and here's the store procedure for get posts. So we replaced the select star with the select column names. And finally, the new record that we added to the link type table, so the static data change that we made to that table. The warnings tab would show you, so if there's any risky changes such as dropping columns, dropping tables, or anything that could result into data loss or tables being rebuilt, then you will get warnings here. So in this case, there are no warnings. Had I not taken care of that column addition change through a migration script, then I would get that same warning that we saw in source control in here as well to let us know that these changes could result into deployment failures. But we took care of that with migration, so for that reason there is no warnings here. So now let's take a look at the update script that we generate. So the first thing that we do, so for migrations to work properly, we add a deployment metadata table to your higher environment. And we keep track, through the table, we keep track of what migration scripts you've already executed and what migration scripts are pending to be executed on the target environment. So if this table doesn't exist, we go ahead and create it, as you can see here. Generally with migrations, SQL Compare will try to run them as quickly as the first thing. So if it can run a migration script as the first step, then it will do that. And that's how basically Compare deals with migration scripts. And therefore here you can see it's trying to deploy the migration script that we saved for the vote type table for adding the new description column. And the way that SQL Compare does migrations is that at first it makes sure that the target object is at the right state. And the way it does that is by saving a patch file into source control, which keeps track of what state the object needs to be at before this migration script can be generated successfully. So for instance, if you're deploying to a new database, then obviously the script that we saved off would fail, right? Because the table needs to exist first before we can run an alter on it. So what Compare would do is that it will create a table, get it to the state that it was before we created its migration script, and then it will execute the migration script in it. So if I go back to my GitHub real quick, just to show you the files that we put in source control. So with each migration script, we store 2 subfolders in source control. One is called auto, the other one is called user. The user folder keeps the migration scripts in it. The auto folder keeps that patch file that I mentioned, which stores the state of the object So in this case, a table, before we created the migration script. So what it does is that it compares this state against the target object, make sure that it is indeed in this state. If it doesn't exist, it will create a table, and then it will run the migration script to get it to the new state, post-migration script. So that's what we're trying to do here as part of the deployment. So as you can see here, it's broken down into two sections: changes before migration script. So there was nothing to be made, no changes to be made, because the table is actually at the right state. So it didn't need to do anything here. So you can see it finished that part, and then updated metadata table to say that now we're deploying this migration script, and then it ran our migration script that we provided, and then updated metadata table to say that this has now been deployed. And then it just continues with the rest of the deployment. So any other objects that it needed to deploy, it just generates a script for those objects and deploys them as part of the same process. So here's the alter procedure. Here's the insert for that new record that we added, and everything is nicely encapsulated into a transaction. So if any part of your deployment fails, then it will roll back the transaction to the beginning. So I don't know how many of you are familiar with the SSDT process. So if you were to deploy, these type of changes with SSDT, you would have to do pre and post deployment scripts in Visual Studio, and obviously they don't run as part of the same script or the same transaction. So if you executed pre-deployment script successfully, but the deployment actually failed, then rollback of this pre-deployment scripts would be manual process. So in this case, everything's nicely handled through a single transaction. So this is what you would review. So if I go ahead and promote this to my staging environment, DLM automation would go through the same process again. So it will compare the NuGet package now against my staging or my UAT environment, and it will create a new report of what is being deployed to staging. So if staging matches my testing environment in terms of schema, then I would get the same result, same report. If they're different, then I would get a new update script that might be slightly different from what we executed on the testing environment. So in this case, it's going to create that, and it will stop the deployment for the manual intervention, so we can manually review the deployment before it goes to my staging environment. Any questions, Steve, at this point while this is running?
Yeah, absolutely. Let me actually kick off our release poll real quick, and then we can discuss a couple things. So somebody was asking, in terms of, they have a web application right now that they deploy with VSTS and Octopus, and so they get cumulative changes for the web application, but when they're making database changes now, there's a single change in each build or package. So that works fine in test, right? Because they just deploy one change, see if it works, deploy another change. But in prod, they want to deploy a bunch of stuff together. So can you talk a little bit about that with DLM automation? I mean, I tried to describe it, but maybe you can talk about it a little.
Yeah, absolutely. So as Steve mentioned earlier on, we basically carry the state of the database in source control. So depending on what source control branch or folder from source control you're triggering your builds off of, our DLM automation will basically capture the state of the database that is in that branch. So let's say that you've made 10 changes into that specific folder that you are building from or deploying from in source control. So that will basically gather the state of the database, which includes all those 10 changes that have been applied to that source control folder. And then we compare that state against the higher environments when it comes to your releases, to basically give you one single update script which includes all of those 10 changes, similar to what I did here. So as you saw, I did 2 separate commits into source control, and then ran a build on that. But I didn't have to run multiple builds just because I had multiple changes in there. All I need to do was to run a build on the latest state of database in source control, and then package that up and then compare that against my higher environments to generate the deployment script.
Yeah. And one other quick question. There's a few more, but I'll wait a little bit longer. But somebody else is asking about seeing the changes. Do they have to review the script or see the diff? Can you just show the changes at HTML again?
Yeah, absolutely. So yeah, so here, you can see my deployment to staging is now waiting for my manual intervention. So again, if you're using Octopus Deploy, then you will receive an email notification to let you know that, hey, you've got deployment to review. But in this case, I can just assign it to myself and review it. So I'm going to open up the changes.html file. This is specifically for the staging environment. So you can see the same changes are being applied. So again, the new column that we added to the table, the modification of the store procedure, and the addition of the new static data to our linked types table. So we kind of follow the Git, I guess, syntax here in terms of showing how the object definition is changing. So one nice thing about keeping track of the state of your objects is that you can actually easily go back into source control and see the history of individual objects. If you're putting incremental change scripts in source control, then if you're doing that manually, then there is really no easy way of knowing how an object has changed over time, because all you're doing is just adding incremental scripts in source control. But in this case, we modify the same scripts, same create scripts for individual objects, so that way you can keep track of how an object has changed, throughout a project. And then the warnings tab, as we mentioned, so if there's any risk of losing data or anything like that, you would see a warning here. If you're dropping indexes or anything like that, then they will show up here. And finally, the deployment script, which is the script that will run in order to apply those changes that we saw in the changes report. So here's that migration script again that we applied to add the new column, the description column. And here's the script for the rest of the changes that we didn't need to do a migration script for. So Compare just generated the script for those, and they're all inside a single transaction again. So now that I've reviewed this and I'm happy with these changes, I can go ahead and approve this. So the same thing applies to VSTS. So in VSTS, you have a manual intervention step that you can add between your release creation and deployment of your database for someone to review these files before they get executed on the next environment. So depending on what tools you're using, manual intervention may not be an option. So, but VSTS, TFS 2017, or Octopus Deploy, they'll have that manual intervention that you can utilize to do a review of your deployments. Okay, so now you can see that got deployed to my staging environment successfully. So just to double check to make sure that the deployment was successful, I'm quickly going to take a look at my staging database, for instance. So I'm trying to find that. Okay, so let's look at our tables. And here you can see that the description column was added successfully with the default data in there that we provided as part of the migration script. So yeah, it looks like all the changes were deployed successfully as part of this. So my next step would be to go ahead and promote that to production, assuming that our user acceptance test has passed and everything looks good in staging. So we can go ahead and promote to production. But it's going to go through the same steps as we saw earlier on, so I'm not going to go through this whole thing again. So instead, we still have about 5 or 7 minutes, so I'm going to open it up to any additional questions that we have out there, Steve.
All right, so here's a good one that maybe I'm curious how you do. How would this work if you want to deploy changes out of order? So let's say we develop feature A first, and that's going to go from test to UAT to prod. Then you may develop feature B, which may just go from test to prod because you're in a hurry. But what if you have feature C that may go from test to UAT but never goes to prod, right? We decide it doesn't work or something. How do you handle that?
Yeah, so that's a really good question. So the process of, I guess, pulling out a release, you basically need to get your source control to a state that that didn't have the changes from, for example, that feature C release, right? So ideally, the way this works is that through some branching strategy, you would have feature branches in source control. So if you're using Git, then you would create a new branch off of your master. So like if I bring up my Git client tool here, I can, as you can see, I have, like for this project, Stack Overflow, I didn't have any branches, but I can just go in and create branches for individual features. And the way it works is that you would apply your changes depending on what feature you're working on to the feature branch. When those changes are ready to go, then you would merge the changes up to the environment branch. So you would have environment branches, one for test, one for QA or staging, and one for production. And you would have a build process set up for each of those, for merges into each of those environment branches. So if once you merge into your test branch, and that would basically trigger a build to deploy to the testing environment. So the state of your database that you deploy to each environment will be different, and it will be based on what you merge into those individual environment branches as a result. So if something doesn't get merged into the production branch, then that means those changes will never get deployed to production, because you will go ahead and package up your databases for each of those individual environment branches and deploy from those packages directly to the environment. So obviously that will add some complication to the process, because now you need to manage feature branches as well as environment branches. So there will be a lot of merging that would need to be done. But that's really the only way, that is, I guess, the best way that you can go about handling that process. But if the process is simple, if you're just working on features, and if a feature is ready to go, and that once a feature is ready to go, then it goes all the way to production, then you only need those feature branches and a master branch. You merge from feature branch to master, that triggers a build and deploys the feature all the way to your production environment. But if there are cases where you need to pull out a deployment or pull out a release from specific environment, then you would have to have those environment branches as well in order to be able to do that.
Okay. Somebody's saying too they restore their prod to other environments after they deploy, basically to reset.
Mm-hmm.
Does this cause any problems for tracking changes with what we're showing?
Yeah, no, it shouldn't cause any problem. So, I mean, similar to what I did earlier on, right? So I cloned, I spun up my dev environment from a clone of production, which was actually, slightly behind from what we had already in source control. So as long as you have all the changes that you've made to your dev environment in source control, then you can go ahead and refresh the dev environment, and then go to, as long as the dev environment, the database name doesn't change, then your database will still stay as linked. But when you go to the Get Latest tab of SQL Source Control, so if I go in here and say Get Latest, this will then show you what changes exist in source control that you don't have on this refresh database that just came from production, and then you can bring back those changes to the database itself through this tab of Get Latest. But yeah, there's no other anything else or limitations that you need to be aware of. So that's really the only thing. And I kind of followed that same process earlier on. I spun up my database and then went to source control, Get Latest, to make sure that I am indeed on the latest version, and I have the latest development changes in there too.
Yeah. So I agree with Arnie. I mean, what I typically want is I want a known development environment that is a baseline, right? So if you're refreshing from prod because you don't have sensitive data, that's great. If you have sensitive data, you really should have a known set of valid test data that I can refresh for a developer instantly. So if they decide they've made a mistake, they truncate the wrong table, I should be able to reset their development environment instantly, reapply changes from version control, and they're good to go. And I can also use that environment for test, for staging, for everywhere else to be sure that I've got a known good baseline from where I start. That's just common sense development, right? That I have a good baseline that I can start from. So if you should have that somewhere, whether it's a copy of prod or something else, you should have that there. So a bunch of people have asked about Oracle, MySQL, and Postgres. We don't really support any of those. I mean, we just haven't seen enough commercial value in supporting those or SQLite or anything else. So if you disagree, please send a note to sales@redgate.com and just let them know that you'd like to see Oracle or MySQL or something else, because if there is a call for it, certainly I think we don't have a fundamental problem with building it. It's just that we've got to be able to sell it as well. So do that. Let me see what else we have here. So a bunch of questions on rollbacks. We may have to just do a webinar on rollbacks.
Yay! I love rollbacks.
I know. So what do you want to say?
Yeah. So generally rollbacks are tough, and depending on what type of changes you promoted to your higher environment, that might be an easy thing to do with our process. So, for instance, if like looking at the deployment that I just did, right? I could go ahead and go into Octopus Deploy and just pick an older release and redeploy an older release to my current environment to do a rollback. But so what this will do is that it will compare the state from the NuGet package of this release against the current version that I have in my database, and based on that, it will generate an update script. The only part that you might need some manual work is if you have any migration scripts, then SQL Compare does not have an automated way of figuring out what the reverse of a migration script would be. So so it will just basically go with its default behavior for that, and then you have to go in and manually modify that script for anywhere that you've basically handled with the migration script. But if there's no migration scripts in the deployment, then it would be as simple as just reversing the direction to go from a previous release NuGet package to the current state to bring it back to the state that you want it to go. So that's basically rollbacks post-deployment. Pre-deployment, then obviously you basically do that through your source control system. You can roll back commits or roll back changes and then update your development database once you've done that through your source control system. But generally, with databases, and I think Steve would agree to this, roll forward is always the way to go and the easiest way to do it. So if even if it's basically getting your database back to a specific state, then just basically figure out what script you would need to run to bring it back to that state, which kind of, we call it a roll forward as opposed to a roll back. You have anything to add to that, Steve?
Well, so I separate things out. I mean, I really agree with what Arneh says. The thing is for code, so views, store procedures, functions, assemblies, and stuff, it's just like my C# code or my Java code, that I can grab that previous version and I can drop it in there and there's no issue whatsoever, right? Logically, I may have problems. I have to make sure my application works, but I can move that code back and forth between any versions without an issue. And if you'd like to see that, I'd really love for you to send a note to sales@redgate.com and vote for that, because I'd love a way in a task to be able to see my code changes and be able to pick the previous version and just deploy it again, right? Because I think that's
yeah.
For tables, there's no good way to do this, because if I alter a table, right, whether I alter a data type, I alter not null to null or vice versa, whether I add a column, if I roll back immediately, like if I deploy this and I realize I've made a mistake and I have no clients in there, it's easy for me to then say, just undo that change. But it depends on the table, because small tables react differently than large tables. So for us to just say, do this, we could certainly do it, but then some of you would scream at me because you have a billion-row table and it takes an hour and everybody's yelling at you and you're mad at Redgate. It's not Redgate's fault. There's no magical way to deploy changes, right? You have to understand that there's a problem. The other thing is, if clients are in there or if there's any period of time that passes and data gets put into a table, what do I do with that data, right? And again, scale becomes an issue, because how do I handle that data? So really, ultimately, the idea of what we're trying to show you here is you should have 3 or 4 or 5 or 6 environments where you actually test this to be sure it's a change you want to make. You can't move so fast in DevOps that you're reckless, right? The idea is that we produce higher quality software over time, not that we produce more changes that we are just randomly guessing. So
exactly, yeah.
For those table changes, they really require custom code to decide how to roll them back. And really what I would say is you should have a pipeline set up so that as I deploy, I immediately am ready to make changes quickly to roll something back. We're not doing any magic here. All we're doing is automating the same thing you would do manually, but we're doing it so that it's repeatable and you're not making mistakes by doing it manually.
Exactly, and especially if you're doing small incremental changes, then you're less likely to make mistakes as opposed to really big, large releases with hundreds of changes.
Yeah. So I think we're about out of time. There's a couple more questions we'll answer, but let's end the webinar now. Arneh, let me just flip back to me real quick and show this last slide.
Sounds good.
And we want to share the right screen. So hopefully that's up now. Database DevOps at redgate.com. If you've got specific questions on the DevOps stuff, if you've got feature requests, I think sales is better, because the salespeople do a better job of making noise to the developers. So if you want new features, new things in there, please send something to sales@redgate.com. But if you've got DevOps questions, or something that Arneh showed today, send it to Database DevOps. We've got more information in /solutions and /training, /finding consultants. We have a number of partners all around the world that can help you better understand and implement some of these things, because the technical side is not too bad. It does help to understand the steps, but really the cultural side and how you'll change things is important. So it is helpful to do this. Another thing is, Arneh's shown you this really quick. Arneh and I could both probably set this up in a few hours in your office, but it really takes you months and months to kind of culturally understand how do we want to maybe alter our development slightly and make it smooth or flow smoothly through. So just be aware of that. As I mentioned, we do these webinars every month, and we change our product mix. Arneh, I don't know what we're doing next month. Do you?
No, I need to go back to our notes. I know we've got it planned out, but I can't remember top of my head.
Yeah. So we are going to try to focus on different areas. I think we focus on just migration scripts one time, and maybe we just need to do a rollback one. But keep an eye on the Redgate site, because we do try to announce different ones coming up. So do that. If you've got questions, again, please feel free to contact either Arneh or myself, or databasedevops@redgate.com, and we'll answer them. And with that, Arneh, thank you very much. Why don't we call it a day, and then we can answer a few questions once we're done with the recording.
Sounds good. Yeah, thank you, Steve. Thanks, everyone.